Hey, welcome back to your favorite technical math class. Today we're going to do an introduction to rational numbers. So if you remember the set of integers, which consists of all the natural numbers, the whole n0, as well as their negatives, if you take an integer over another integer, where a and b are integers here, then you'll have a rational number. And notice that the natural numbers, whole numbers, integers, they're all subsets of the rational numbers. You know, if you take like 4, you can express that as a rational number, 4 over 1. But any rational number like negative 2/3 is an integer over another integer. Now, fractions we kind of use loosely in everyday life, but technically a fraction has to be a positive natural number over another natural number, right? Otherwise, it's a rational number. Like negative 2/3 is a rational number. Technically, that is not a fraction. A fraction would be 2/3, right? Where you'd have 2/3 of a pi. So no negatives technically with fractions, but you kind of use that term loosely in everyday life. Now you have two types of fractions. You have proper and improper fractions. Proper fractions are where the numerator is less than the denominator. So 3/4 is an example. Notice the 3 is less than the denominator of 4, whereas with improper fractions, your numerator is greater than your denominator is an improper fraction. Now, what we're going to do is write equivalent fractions. You know, for example, 1/2 is the same as if I multiplied the top and the bottom by 2, I would have 2. 1 times 2 is 2. 2 times 2 is 4. 2/4 is the same thing as 1/2, right? If you multiply the top and bottom by 2 again, then you would get 4/8. And you know, 4/8 is the same thing as 1/2, right? 2/4 is the same thing as 1/2, right? 4/8, same thing as 1/2. Let's go ahead and fill in the blank to create an equivalent fraction here. If you notice on the bottom, this is an improper fraction. You got 5/4. And we're trying to create a fraction with a 16 as our denominator. So you think to yourself, well, 4 times what is 16? And hopefully you know that 4 times 4 is 16. So as long as you multiply the top as well by 4, 5 times 4 is 20. 20/16 is the same as, since 20 factors into 4 and 5, 16 into 4 and 5, it's the same as 5/4, isn't it? And let's talk about officially reducing fractions to lowest terms. What I'm going to do is I'm going to factor the numerator and denominator and then cancel out the factor. So if you look at 24/30, if you factor 24, you're probably thinking, well, I know 4 times 6 is 24, and I know 5 times 6 is 30. Now, I do recognize you can go further with that, but notice that the 6's cancel, right? And even though 4 can still be factored into 2 and 2, 5 you're stuck. It's just 1 and 5. So you just go ahead and leave it as 4/5. So 24/30, the same thing as 4/5. Let's do another one. How about 12/80? And so 12, you got like 4 and 3. Of course, you can keep going with the 4. That's 2 and 2 and 3. And then 80, how about 8 and 10? But we can keep going with the 8. 8 is 2 times 2 times 2, or 4 times 2. There's our 8. And 10 is 2 times 5. Well, we know 2/2 is 1, so those cancel. We know we have another 2/2, which cancels. And so it looks like we're left with a 3 on the top, and then 2 times 2 times 5. 4 times 5, we got 20. So 3/20 is the lowest, is 12/80. Same thing as 12/80, but we have reduced it to lowest terms. Now let's look at some mixed numbers now for a minute. So mixed numbers have a whole part and a fraction, like 2 and 2/3, which means 2 and 2/3, right? Or -6.5, which is -6 minus a half. And we're going to go ahead and convert those to improper fractions. So let's, what you do is you take the 2 times 3, so 2 times 3, and then you add, so you times here, and then you add the 2 right there. And then you put it all over that 3. So 2 times 3 is 6, 6 plus 2 is 8/3. 8/3 is the same as 2 and 2/3, right? Let's do another one here, 5 and 1/4. So I'm going to go 5 times 4 plus 1. 5 times 4 plus the 1 on the top, and then put it all over the 4. And so this ends up being 20 plus 1 is 21/4. 21/4 is the same as 5 and 1/4. Right, that's 21/4. Now let's go ahead and do an improper fraction to a mixed number. So here's where your long division would come into play. You put the 13, the 13 in the box, it's at the top of the list, right? You're at the top of the list, so they get in the nightclub, if you will, and the person at the bottom of the list is outside the nightclub. There's your little Vegas way of remembering who goes in as your dividend and who's your divisor. So we're dividing 13 divided by 3, and if you remember this division algorithm from grade school, you say, well, 3 goes into 13 how many times? If I'm trying to match that 13, but I can't go more than 13. So like you're like, well, 3 times 9, 3 is 9. I want to go, how about 4? 4 times 3 is 12. Okay, it's going to be 4. I can't go to 5 because 5 times 3 is 15. That's more than 13. So we're going to go with 4, right? And if you're not sure, just punch in on a calculator, go 13 divided by 3, and you'll get 4 point something. So you know it's a 4. Now I'm going to multiply. 4 times 3 gives me 12, and I put it right there, and I subtract that. And this is my remainder. So the answer is my quotient, 4, plus the remainder over the divisor. Quotient plus remainder over divisor. And that's how you do 13 divided by 3. All right, so maybe we'll do another one. How about 23 divided by 3. So let's do the long division. 23 divided by 3. So I say, well, 3 times 8 is 24. That's too big. So let's go 7. 7 times 3, there we go, is 21. I got to go less than 23. And then I subtract it. 23 minus 21 is 2. So our answer is quotient plus remainder over divisor. So 2/3. 7 and 2/3 is the same as 23 over 3. All right, now let's go ahead and write these decimals as fractions in lowest terms. And if you remember, if we can read this, that would be very helpful. So if you remember, that's our tenths position, the first decimal. That's our hundredths. Third ones are thousandths. Thousandths, the D in there. And then 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths, and so on, right? So if you were to read this, I'm going to do this two different ways. I'm going to read it as my method 1. This is in the second position. So that's read as 8/100ths. So I write that as, that's the fraction form. Now it's not reduced to lowest terms. So I do need to break that up. You know, that's 2 times 4. 100's 10 times 10. The 4 I can still break up. The 4 is 2 times 2. The 10 is 2 and 5. And 2 and 5. So 2 over 2 cancels. There's another 2 over 2. So it looks like I got a 2 on the top, and then I got to multiply those back. 5 times 5, 25. So I got 2 over 25. That's 8/100. So that's method 1. Method 2, there's a different way to do this. Let's go ahead and write method 2. And that's to write the 0.08. Go ahead and put it over 1. And then what you want to do is you want to multiply the numerator and denominator by 10 to the n power, where n, in other words, how many tens you're multiplying it by, is how many the position, the number of decimal places. So this, see how it goes to 2 decimal places? The 8 is, there's 2 decimal places where it terminates here. So I'm going to multiply by 2 tens, which means I got to multiply the bottom by 2 tens. So I'm multiplying the top and the bottom by 100. So 0.08, and I punch this into my calculator. 0.08 times 100, or 10 times 10, that gives me 8. And then 1 times 10 times 10, that gives me 100. And we know that reduces to 2 over 25 because we just did that above. Okay, so there's a couple different ways to do that. I'm going to do it with a method 1 each time. Let's go ahead and look at this next one. The 5, notice it ends at the 5 here. Whoops. Is in the thousandth position, tenths, hundredths, thousandths, the third spot. So I'm going to write that as a 125 thousandths, right? So as long as I can read that, I should be okay. And then 125, that ends in a 5. Remember, if it ends in a 5 or a 0, it divides into 5. So that's 25 would be 5 times 25. Would be 125. Now 1,000, I'm sorry, is 10 times 10 times 10. So let's keep going with that. The 25 factors into 5 and 5. The 10 would be 2 and 5, another 2 and 5, and another 2 and 5. So notice 5 over 5 cancels, right? That's 1. 5 over 5 cancels, that's 1. And then 5 over 5 cancels. So I'm just left with a 1 on top, right? 1 times all this. So I have a 1 on top, and then 2 times 2 times 2 is 8. So this 125 over 1,000, 0.125, is just 1/8. And let's do one more here where I've got 6.22. So that's 6 and 22 hundredths, right? The second position is hundredths. So I have 6, and then I'm going to break up that 22. Well, I could do this a couple different ways, but let's go ahead and convert this to an improper fraction. So I'm going to go 6 times 100 plus the 22. So 6 times 100 plus that 22, and then this is all over that 100 on the bottom there. So I got 600 plus 22. I got 622 all over 100. And so then I'll just factor that. So 622, let's see, that goes into, that's even. So that's 2 times 311. I think I'm done at 311. And then 100, that's 2 times 50. I know I can go further with 50, but I cannot go any further with the 311. So it looks like I'm actually done right there with 311 over 50. All right. All right, let's keep going here. A couple of examples of some repeating decimals now. So this 0.6666666, see how the 6 just keeps repeating? So we would write that as 0.6 repeated. This next one has got 0.8181818181. See how the 8 and the 1 repeats? So we would write that as 0.81 repeated, right? The 8 and the 1 repeated. Now there's an easy way to convert these to decimals. And what you do is you write the repeating digit as the numerator over that many nines. So for example, this 0.444444 right here, right? So 0.4, there's only one repeating digit. And so you put that 4 over 1 9, because again, there's only one repeating digit. So if you were to punch in your calculator 4 9ths, you'd see 0.44444444 and so on. Let's do that same thing here, 0.66666666. So you put that 6, and notice there's just one repeating number, so you just put over 1 9 there, excuse me. But this is not in lowest terms. 6 is 2 times 3, and the 9 is 3 times 3. So this actually reduces to 2/3 on that. Let's do this 2.81 here. So 2.81, that would be 2 and 81. Now notice there's two numbers that are repeating. So I'm going to put it over 2 9s, 99. 2 and 81 99ths. So this would be the same as 2. I'm going to leave the 2 alone right there, but 81 I'm going to factor into 9 times 9, and the 99 factors into 9 times 11. So it looks like I'm left with 2 and 9 11ths. Or if you wanted to multiply 2 times 11 plus the 9 on top all over 11, I've got 22 plus 9, that's 31 over 11 is the same thing. All right, and finally we'll finish up with some easy changing fractions to decimals. So you just take 3/4. So you go ahead and divide that. And so let's just go ahead and pull up our decimals scientific calculator here. So I'm going to go to decimals.com, and I'm going to punch in, click on Math Tools Scientific Calculator, and then we just go 3 divided by 4. You can take the 3 divided by 4 there, and then hit enter, and you see that 0.75. And there it is as a decimal, right? And same thing if we punched in 7 9ths, what you'd see on the calculator is 0.77777777. Anyways, it keeps repeating, but this is asking us to take it to the 1,000th position. Right there's the 1,000th position, the third decimal place. So I look at that number to the right, and it is greater than or equal to 5, so I'm going to bump it up. So this will be rewritten as 0.778 once I round that up. And that's your decimal approximation to the nearest 1,000th position. Well, thanks so much for watching part 1, Rational Numbers. We'll see you guys next time.